We are going to talk about Frida today. I mean, the talk is named as Frida Unleashed, so we submitted the talk. We put a fancy title because we need to get selected, and then we were like, we're not going to talk anything really unleashed stuff. It's not going to be like innovative research. The aim of the talk is that we are going to talk about Frida, and then we will hopefully convince you by the end of the talk that you will go back and use Frida in your mobile pen testing. So yes, again, the reason why we called it scratching beneath the surface is because in our experience, right, Akshay does a lot of mobile pen testing. I don't do a lot of mobile pen testing. I do use Frida, but for various other reasons. But what we have noticed in bug bounties, right, especially mobile pen testing, I think Rahul and they have asked the similar question, right? How many of you do mobile pen testing, like actively in bug bounties? Cool. How many of you use Frida for any reason, bug bounties or anything else? Cool. Few people, which is good. You are in the right place. If you are a Frida master, definitely there is not a lot to learn here. There is a great talk going on in the main track. Cool. Anyway, so we have noticed that not a lot of people scratch beneath the surface. I mean, one of the primary things that we hear in bug bounty is that there's a lot of people and then you can't find bugs. All of them are duplicates and things like that, right? But if you can go beneath the scratch, you can find fantastic bugs, and we'll sort of hopefully prove it by the end of the talk. So enough of it. Oh, that's both of us. If you want to put a name to the face, that's both of us. Akshay wanted me to definitely say that he's a Web 2 security expert. I'm not sure. Yeah. Anyways, cool. So why this talk? I won't spend a lot of time on this, but essentially the reason why I'm talking about it is because mobile security is nuanced, right? You have a bunch of ecosystems, you have a bunch of security protection mechanisms. It's not like web security. Web security, you just open a web application in your browser, you set up burp, send the certificate, and you just start pen testing. But mobile security is definitely not like that. You have a lot of nuances to it, and it gets tricky. You have SSL pinning, you have root detection, you have encryption, bunch of things that go on there. And mobile security testing is daunting, which again, it's not like web security, right? You have to do a bunch of things. The setup is hard, and then you need to do a bunch of testing. This is something we have noticed as well, so that's why this talk. And the last and most important thing, this is where Akshay comes in. Mobile security is full of tribal knowledge. When I say tribal knowledge, right, it is undocumented knowledge. So people who have been doing mobile security for a while, people who have been using Frida for a while, they know a lot of security things which are not really documented. There are things that Akshay does, and I'm like, can you reveal this? So there is a lot of tribal knowledge, and we'll try to share it. And the last important thing, this is my selling point, which is it's fun. If you learn Frida, it's not mobile, right? You can use it for a bunch of other things. I'll sort of show you that as well. But breaking down protocols or breaking down binaries, hooking into functions, and then making it do different things, that's actually fun. So Frida is a dynamic instrumentation toolkit. Essentially, when I say dynamic instrumentation, right, or if you have done any sort of debugging or instrumentation, it is basically running a binary. You can inject yourself into a live process. Again, a lot of people who have been using Frida, they might be using it in the context of Android. Frida is a dynamic instrumentation which is agnostic of platform. You can have native apps on Windows, you can have a Go binary, you can have a C binary or anything like that. A black box binary or a package, you can inject yourself into it, and then you can play around with the binary or package or functions or methods. This can help developers, reverse engineers, security researchers, but primarily we are going to look at security researchers. But the most important thing with Frida is that you inject yourself into your process, but when you are injecting yourself, you are also injecting a JavaScript V8 engine. So you are inside a process, there is a process running, you are inside the process now, and you have the full capability of JavaScript. And when the first time that I heard it, I was quite amazed and I was quite surprised that Frida is free. Because the capability to inject JavaScript engine into a process and then being able to control, that you can send that tool, but then it's good that this tool is free. And the last point, that is the great point, is that it has fundamentally a lot of APIs. You can use this API to build your own tools around it. We'll also take a look at that. So essentially, it's not just Frida. You can build tools. You can build your own in-house mobile pen testing framework if you want to. We'll look at a framework like that. So, but the takeaway is it's a dynamic instrumentation tool. You can inject yourself into any process, and you have full capability of V8 JavaScript. Like the way I say it, what you can do with a package is only limited by your knowledge of JavaScript and your imagination. You can do anything. You can do everything on top of it. And again, I won't spend a lot of time on that. We'll look at the first thing. So if you want to use Frida, right, this is completely in the case of mobile pen testing. You have multiple modes. We will sort of look at the first mode. It's called injected mode. Essentially, in injected mode, you have Frida server that will be running on your mobile device, and you have a Frida client. From the client, you can talk to the server because it opens up to 27,000 or something. So your client can send commands, and then your server will talk to it. And basically you can use this to hook, and you can do a bunch of things. The second mode is embedded mode. So the first mode, injected mode, is good if you have a rooted device. If you don't have a rooted device, or if you have a restricted device, then you can use embedded mode, which is you take a shared library of Frida. You can actually patch your application, and then you can make it part of it. But embedded is a little tricky, but you get more functional. You can do more things with it. Injected is a lot easier. Again, that's my opinion. But you can look at the mode side. Again, there are tons of tutorials around it. I don't want to spend time where you can learn on tutorials. I'll just go to the next part where we'll talk about how we use it. And the way I'm going to do this talk is that we're going to talk about a bunch of hurdles, right? So I'll talk about a bunch of problems that you might face when you're doing mobile app pen testing, and how do we solve it using Frida. We look at an easy way, we look at a harder way of doing it. Cool. So the hurdle one is root detection or jailbreak detection, right? Again, when I'm talking about these hurdles, we'll go from the hurdles of installing the app, and we'll take you till how you can find vulnerabilities with the app. So it'll all make sense when you look backwards. So just bear with me. So first thing is root detection or jailbreak detection, right? Essentially, most of the web applications these days, not most, all of them these days have root detection or jailbreak detection. This is like the baseline security. If you come from the defense side, if you have an application that you're responsible for, you should have root or jailbreak detection. And it is pretty much prevalent because there are a lot of tools that make it really easy. Basically, they look at a bunch of packages that should exist. They look at a bunch of parameters in your mobile phone, and they will decide if it's rooted or if it's jailbroken, and they'll detect it. And this is the first problem, because if you want to test a mobile application, you would sort of want it on a rooted device because you want to play around with it. And the normal Android, the permission set is very restrictive, and you can't do a lot. This is the first hurdle that you need to jump. And the easy way is quite straightforward. There is a tool called as Objection. This is built by, I think, Leon Jacobs now. So this is a tool that is built on top of Frida. Essentially, this uses Frida APIs, and it does a lot of automation. You can use Objection. I'll show you how to do it. And if any of you have done any amount of mobile pen testing, right, you might have used it, because it's a one-liner to just bypass root detection and jailbreak detection. So you can use Objection. It's a tool. I'll show you. But my favorite way, and this is what you will end up with if you are facing a harder target, right? If there is an application where you can't use Objection, you use Objection, but you can't bypass root detection because they have a little more of checks. That's when you need to go to Frida hooks. Again, Frida hooks is not a tool. It's basically a terminology. Like when you do dynamic instrumentation, hooking is a technique by which you hook into a function. If there is a function in your Java which is going to make this root detection or jailbreak detection, right? Using Frida, you will find this method or function, you will hook into it, you manipulate it to disable the check. We will get into the details of it, and then there are a couple of other things also that you can use, Magic plugins and expose, but they are not Frida, so we're not going to talk about it. And I was talking about Frida hooks, right, which is you basically write a piece of code, you execute it, and then it can bypass things for you. But again, you need to write JavaScript here. The interesting bit, and this is the most important key takeaway that I want you folks to take home, which is you don't have internet. We'll just quickly show it to you, but if you come from the application security world, right, if you use Burp Suite, there is an extension store, right, extender or something like that, where you get a bunch of extensions which give you capability to do a bunch of things. Like you have scanners, you have active scanners, /forward scanner, things like that. So Code Shell Frida is exactly like Burp Suite extensions. People have put in effort, people have written code that can do certain things. There is universal Android bypass, there are a bunch of things you can do, and the code is available for free. And you can even run it from your CLI directly, you don't even need to download anything. We'll see a bunch of them. By the way, we don't have demos, we only have screenshots because Akshay a couple of times has burnt his hands trying to do demos, and they're not really visible on the slides. But we will share a bunch of things, and there's also going to be a blog post. And quickly deviating from this, we'll also probably do like an 8-hour free training on Frida because we would want people to use it probably in the next couple of months. But Code Shell Frida is pretty good. There are some amazing scripts over there. You can just get it out of the box, do fantastic things with it. So if you are using Objection, you basically run this command against your package, and you would be able to bypass root detection or jailbreak detection. The most important thing is the last part, right? Android or iOS is a keyword, whichever operating system you are going against, and root disable is a keyword where Objection will understand. Again, it's a framework. It will understand that it has to disable the detection, and it will do it for you. Will it be successful? Most of the times, but not all the times. Actually, we'll talk about the times when you will fail and now what to do. And there is also other keywords, right? SSL pinning, disable, and other things. So Objection is a framework that does a bunch of things, but In this case, you can do a root disable, but you will fail sometimes because mobile pen testing is nuanced and not all the times you can use objection, right? Because most people would just run objection and they'll be like, I can solve this, but then they might not be able to solve. But this is the most important form. This comes from our experience, which is what happens when the tools fail. Do you want to take out?
Hey, hi folks. So basically, we will be talking about what happens when the automated scripts or the available tools fail for bypassing. It can be root detection or it can be the jailbreak detection. So we need to really be sure about what the application has been actually been using, whether it has been using some sort of open source library or is it some sort of custom libraries. But yeah, depending upon that, we can actually start attacking the application. These are very few of the syscalls which are pretty interesting. These can be used to actually identify what's been happening with the application, because even for example, even if we use it in Java, for example, java.io.fileopen, eventually deep inside it will actually call the libc library, and then it will perform that particular action. For example, the first one is /box/star. These star is something which I cannot specify all the things, but it definitely contains some of the mount info, some of the memory info, what's getting mounted on this particular process, how's the memory being defined, what permissions does it has. Second is the p open and the f open. These are basically points to the pointers or the file operations which you are doing for maybe reading a particular or maybe opening a particular file. Third one is the get environment. This basically gets you the environments of your Android device, which can be used to identify what's the state of the device. And the fourth one is again the stat parameter. It's another syscall which can be used to identify the stats of the device, and then depending upon that we can identify whether this is a real device or this is a emulator. Yeah, and there are a bunch of other syscalls also. So basically you can just run the script, and then here you can just place your binary. It will start hooking into all the syscalls which are being present in your application or which your application calls, and then it will start printing key what syscall is being invoked, what hasn't been invoked, and then depending upon that, this will work on the unobfuscated prints. But if you are going against applications which have some sort of string operations, ambient operations, then we have to deobfuscate them, and then only we can perform this thing. So this is the example of the early instrumentation on the Java side, where the framework gives us the Java de-optimized everything, and then we can just use the Java perform call, and then we can start inserting our own logic, and then we can perform the operations. This is only used for early instrumentation on the Java applications. But if you want to use on the SO files or on the shared object files, then we have to use something like this, where we have to call that particular ELF constructor, and then generally we use it to call it using JNI onload, and then using that we can again call this particular function called call array. Using this, we can actually start doing the early instrumentations on the mobile applications which have the significant code written on the NTK side. So this gives us the advantage of using it. Here you just have to list down that particular library, below, go down, and then you should be good to go. You can start writing your own logic. What happens, what fails, and it's good to go. So I generally say it as a case study. Bharath says is a quick tale from the trenches. So yeah, so 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 we were looking at a private bug bounty program which had mobile application in the scope. We had the early advantage as we got invited just after a month of the program launch. People the program description had something written ki no one has actually reported the bugs in the mobile application, so whoever reports it gets much more bonus amount. There was some multiplier by bonus amount to which there was so we were like, why not, let's hunt on it. We started pulling the application from the Play Store. We ran this tool called EPCAGRI, which helped us in actually finding out what particular RESP solution is being implemented on this mobile application. We found out it was a pretty naive RESP solution, so we started attacking that application. So we figured out there was root detection methods which were in the Java language. So we actually wrote a simple hook, and then we found out whenever we were hooking into those functions, the applications would crash, and then it will start showing us the logs that the application is being crashing due to root detection. Then we started looking much more deeper into the application. Then there was this particular SO file where we found out the logic which was written for the root detection. We took that memory address, we actually bypassed it, just set it to false, and then voila, we were able to bypass the root detection. But now, what's something strange was this with this mobile application was that they only were depending upon the root detection. They didn't even have the SSL pinning. So once we got onto the APIs, we started finding very trivial issues, like for example, some very basic SQL injections, some very basic IDOS. We reported to them, and then we got it fixed. But what we have learned here is the things to attack were always there, but we just didn't know where to do it. Here we just had to do the early instrumentation for the Java and for the SFI, and then we identified that particular function which was responsible for doing the root detection, and that's it. Tools were always there. It's just we didn't have everything at one single place. Now let's just say you have the mobile application. You found out where you were able to bypass now the root detection or the jailbreak detection. Now you're not able to actually intercept the traffic. It works on the same logic for the browser. We have this particular CA systems. It checks for this particular pin certificate or the public keys, whether they are there. If they are not there, then things will start to fail. And using that we can perform the MITM. So these are few tricks using which we can bypass certificate pinning on the Android or the iOS applications. So, for example, we have Frida scripts which are commonly available on the CodeShare platform, which actually hooks into the various networking libraries and started giving us the traffic. Second, we have again is the Objection tool. Objection has a pretty nice function where you have to just do Android SSL pinning disable, iOS SSL pinning disable. It will again attach itself to the application and start returning those methods to actually false. Third is the hash replacement. So basically, developers tend to hardcode the public keys or the public certificates inside the application. So for the Android, they have this library where we can use network security config.xml, and then inside that, where we can actually define the particular hashes of this application should only communicate with this server. And then same goes for the iOS. iOS also, there's something called info.playlist where we can go ahead define the public key. And then we have this plugin called SSL kill switch. It's another nice plugin which can be used for the iOS applications. And then we have the Flutter. So Flutter is a new framework which is quite popular right nowadays because it just write once and then run anywhere. You can run it on iOS, Android, everywhere. So basically, with how Flutter works is a bit different from the general applications, because Flutter comes with its own set of the CS certificates. So there we have to actually identify which of the function is actually doing the operation, and then we have to just hook into that particular function and then return false. And then we have the TLS verification false, SSL pinning bypass. Same goes for the React Native applications. They have their lot of logic written in that index bundle file. So you can go there and start implementing breakpoints and then setting up things, disable it, identify the function, and then you are good to go. Now here comes the interesting part. Now what will we do when the automated tools or the scripts fail? Now when we try to, we have the application, we are not able to intercept the traffic on our proxy. Now what? Now we have to go deep. We have to start identify with what way the application communicates with the server, whether it uses some sort of custom protocol or it uses some standard protocols. We have to identify the network stack which the application uses. It can be OK, HTTP, it can be Volley, it can be any other networking stack which might be available out there. If they are using the open source network stacks, then we always have the source code for it. We can find out the function, we can start hooking into that particular function, disable it. Now let's see, we are a consultant, we don't have much time to actually now bypass deep pinning. Now what we will do? Apparently, every OS has its own set of SSL stack. Android comes with its libSSL, where they have the function of the SSL read and then the SSL write. We just have to hook into those particular methods, and then we can start dumping the traffic on the terminal or whatever terminal which we are using. And then there are custom ones. So there are applications like Facebook, Instagram, which comes with their own SSL stack. They don't really depend upon the OS SSL stack. So the only way to bypass those is we have to get the SO files from the application, start looking into the functions. What do they do? There is generally SSL underscore verify disable functions, because developers also need to get the logs in the plain text so they can understand why the application crashes or for some other reason. So they generally don't tend to obfuscate the NDK side of code. So now this is again one of the examples. Now what we will do if we have the SSL pinning on a custom library. This is a game. It's written in the Cocoa. We are here now. We have to actually go into the particular SO file, and then we identified there was the SSL write function. So now we just have to start printing that. Now there are two functions where there's one is the SSL write and then there's an SSL read. So basically, I'll tell you what this script will do is, we are actually hooking into this particular SO file, which is the Cocoa dependency. It's generally used for games, and now we have the SSL write functions, which will actually start dumping the traffic. So we will actually be able to see what traffic goes from the mobile application to the server, and then maybe we can start playing around with it. Now, now you guys might have a question. What if this also doesn't work? Luckily, Linux comes with its own libc, so we can always hook into the send function and then get the data. But the only issue is it's quite thread intensive operation. So there are really good chances that the application will start crashing, or your OS might go into the kernel panic mode. But that's the only last option which we have. So now we have bypassed the root detection, we have bypassed the SSL pinning. Now when we get to the actual traffic, we see the request and the response are in the encrypted form. Now it's again, we have to go back to the basics. If things are being encrypted, traffic has to go from the mobile application, right? So the encrypting functions will also stay on the mobile application itself. We have to start identifying it on how to go further on it. So these are the common techniques to figure out the encryption logic. We can just, if the application communicates on the AES encryption, we just have to use this Frida code share, this script name -f, and then the package name. That is it. It will start printing the traffic on your terminal, and from there we can start playing around with it. Next again, objection comes. Objection provides two features where we can start manually saying we want to hook into this particular function, and then the objection has the capability to identify encryption in the iOS applications. But then again, how it does this? It actually hooks into this particular method, this particular library, CCCrypt. And for the Java, it's for generally developer uses Java X crypto library, and from there we can start identifying what's being encrypted, what's being not encrypted. Now again, we are back here. For some reason, none of these things work. Now we are back to the basics. Apparently, Frida has this thing called Frida trace, where I just have to put that particular string. ENCRY, if I'm looking for the decryption, TCRY, I can start looking for the various famous algos, for example, SHA1, AES, and then it will start identifying in that particular functions or in that particular classes, and then it will start telling you. One of the really amazing things about Frida traces, it will create a handler file for you. Now, you don't even need to write that particular JS, that particular tracing function. It has already done it for you. Now you just need to open that particular JS file, write your logic in that particular interceptor function. That's it. You should be good to go. These are apparently non-case sensitive, so even if the encryption is written in the capital letters, we don't care. We can use the star because developers generally tend to not to write encrypt. They will generally try ENCRY or maybe DCRY, and then but luckily we have Frida trace to the rescue.
Yes.
Now let's just say this won't be coming much, but this will come for some of the very well secured apps. Let's just say now you are onto as soon as you attach Frida to that particular application, the application crashes. Now, how will we actually identify? So basically, the developer can write a logic where they can identify if if the application is actually attached to the objection tool, then the objection renames the Frida binary to actually FREDA binary. If we, but certain REST solutions tend to check for that particular process also. So the best way would be download the objection source code, and then find out where this particular function is, and then actually rename the Frida to maybe your name or something else. Then very naive REST will actually let you bypass it. Now, next is the bypassing string-based search. Then again, since Frida is just a server, it will create its own memory maps. There we can /proc process ID /maps, and then there we can start looking for the Gmail, or we can start looking for the V8, or we can start looking for the words Frida server, and then various unique strings which are being used by the Frida tool. Third is the bypassing memory-based search. This is something which I have rarely seen, because implementing memory-based search is very tough, because you need to have the very much clear idea on what devices your application is actually running, and then depending upon the architecture also, memory addresses will change, so you have to be very clear where does your application runs. This is something very rarely I've seen. One of the most common ones I've seen is the port-based detections. Since Frida runs on the client server, right? Mobile, laptop, PC, whatever. There's this particular port which gets opened on the mobile application, 27042, I think. So the applications will start sending packets, or will start picking that whether that particular port has been opened or not, and then we can actually start and then if that particular port is actually there, then the application will actually crash. But if that particular port is not open, but then the application won't crash. So these are the few things. So now the easiest one to do is for the lazy people, we just for the bypassing port-based detection, we just have to hook into libc connect function, change the port to 1337, and then you don't need to worry about port-based detections anytime. So these are the few ways with we can bypass Frida detections, but then again, there's not much techniques out there. It really depends upon what's being implemented in the mobile application, and then you can start messing around with it. Okay.
I asked Akshay to add this slide because there is this tool called as Frida, which is really fantastic, and I would want to really talk about it. So Frida is essentially a burp extension that you get, which acts as I've just taken this from the GitHub page. So essentially it acts as a bridge between Burp Suite and Frida. Essentially, if you are an application pen tester, right, the ecosystem that you are commonly familiar with is you have your browser, and then you have your Burp Suite, you do your testing. But then let's consider there is this new marketing terminology, or this fancy terminology that came in mobile security, which is called RASP, Runtime Application Security. Essentially, when your application is running, right, they do a bunch of security measures by which they promise you integrity. So essentially, they say that the request that is fired from your mobile application is the request in the same form that reaches your server. So what it means is that if you manipulate the request, right, for example, let's consider that you want to find an IDOR and you have a user ID, and if you manipulate the user ID, there will be a bunch of information that they can add that the server can verify, and it will fail. If you change your user ID or if you change any information, it will fail on the server side. And essentially, this is a very similar thing that happens with symmetric encryption, which is, if let's consider that you have traffic going and then the traffic is encrypted, right? The traffic is encrypted on the device. For every request, you have to encrypt it at Burp Suite level, and then you have to send it forward. So it is a little cumbersome because if you want to do it on Burp Suite, it's going to take a lot of time. This is where Frida comes into picture. So essentially, I'll try to give a mental map. It's a little hard to explain this, which is you have Burp Suite and you install this extension. This extension can actually talk back to the Frida server on your device. So essentially you have a mobile device which has Frida server running on, if you don't change anything, 27,042. You have the server running on your mobile device, you have the API open. Now you have this extension. Let's consider the case of symmetric encryption, right? Your HTTP request or response will hit the burp suite. It is encrypted, and what in this case you are doing is on the device you will have some function or some method that will do this encryption, right? Your extension burp suite Akshay can talk back to this method, do this encryption, and then whatever you change, right? Even if you change it, for the changed parameters, it will calculate it and then it will send it forward. It's a little tricky, but then what I'm saying is using Frida, you are not tampering or you are not manipulating the functions. You are essentially talking back to the mobile application using the feature that the mobile application provides you against the mobile application. If you have encryption happening in a function, your Frida extension is actually talking to the function, but not manipulating the function. You are just talking to it, getting the value, and then sending it forward. So if you are doing mobile app pen testing, and again, you will need Frida only in my opinion, only in case if you are hitting a complex application. But it's sort of fun to actually fiddle around with applications like that. If you have RAS, the most important part being, if you have an application that has runtime application security, most probably a lot of people would give up at that point. It would be fun to actually break the runtime application security protection, go forward, and then do the testing. So that's essentially it. And there are a bunch of people you can follow if you want to learn more about Frida. I do understand that even after the talk, it's a little intimidating, but then it is intimidating or it is a little tricky. That's why it's fun. Otherwise, everybody would do it, and then you would not find bugs. So, I am going to put up the slides. It's going to be available everywhere. I'll tweet about it. Ole Andre is the one who created Frida, I think. Yes. Leon Jogams has a fantastic workshop on Frida if you want to get started with. And even Jiska Klassen, she has fantastic workshops on that. You can follow these people. There is a lot of Frida knowledge to learn. But once you learn Frida, once you understand the ecosystem, you can get past the surface of bug bounties, get to the part where you'll get the vulnerabilities that usually most people will not attempt. So that's about it. That's what I